All right. Good day, everyone. This is Dr. Yahya. I'll be taking computational physics this semester for the postgraduate students. So the course is for both MSc and PhD students in theoretical physics. So the course title is computational physics, but I'm going to be using Python as the programming language of choice, and I'll explain the reason for the choice of Python. The topics that we're going to treat are basics of Python. So because for us to use Python as a programming language to solve physics or scientific and engineering problems, we need to know the basics of Python. Then we'll look at various numerical methods in physics. We'll look at various methods of numerical integration, numerical differentiation, solution of linear and non-linear algebraic equations, solutions of systems of linear algebraic equations, numerical solutions, then least squares and curve fitting, interpolation, statistical analysis of experimental data, numerical solutions of some differential equations in physics. So these are the topics that we're going to treat in this course. Some of the recommended textbooks are written here. Computational Problems for Physics by Robin Landau. So it's one of the standard computational physics textbooks for postgraduate students. Elementary Mechanics using Python. This second text is a textbook for undergraduate students. Essential Python for the Physicist by Giovanni Moruzzi. Scientific Computing with Python, so by Fura, Solem, and so on. Learning Scientific Programming with Python by Kristen Hill. Numerical Methods in Physics by Python. A Primer on Scientific Programming with Python by Peter Langtangen. So this seventh one is also for undergraduate students. Then Numerical Methods in Engineering with Python 3. So these are some beautiful textbooks for computational physics with Python. I will strongly recommend the first and eighth one for postgraduate students, Computational Problems for Physics by Robin Landau, a very, very good book. Numerical Methods in Engineering with Python 3. This is also a very, very good book, but it's simple. It's simpler than Landau's book. So I'll urge you to, I have all the 8, so I can give you all the 8 textbooks, but I will recommend number 1 and number 8 for postgraduate students. Okay, so Python is a general purpose programming language. It's very, very powerful. It's very, very versatile. So it was first devised by Rossum in 1989, and it is one of the high-level programming languages. And it's unlike some of the old programming languages like Fortran or C that are low level. So Python is a high level programming language. So when you compare to programming languages like C, what are the advantages of Python? So, or let me say, why have I decided to use Python programming language as my programming language of choice for teaching computational physics? So number 1 is that Python is very, very simple to learn. Okay, it has a simple syntax and it's very, very versatile. Python is open source. It's free. You can download all the source files, all the modules free of charge, unlike some high-level interpreted languages like MATLAB like MATLAB. So it's free. So then it is cross-platform, but I think many modern programming languages are cross-platform. So you can write a code in Windows and run the same code in Linux or Mac. So you get the same answer, except of course when you are generating a random number. So when you generate a random number with a particular seed, okay, so you have to fix the seed. Otherwise, the random number generated will be different in Windows if you compare it to Unix or Mac. So one of the advantages of Python is that it has a huge library of modules and packages such as NumPy, SciPy, Matplotlib, scikit-learn, and so on. So there are many. So, and you can for each area that you want to apply Python, there will be some modules that will make life easier for you. So if you are a scientist, you need NumPy, SciPy, Matplotlib module. NumPy for dealing with numerical data, large array, large data. The SciPy has lots of functions, special functions, solving integration, solving differentiation. The functions are already written and they are in SciPy. So solving ordinary differential equation, partial differential equation, and so on. So you can use SciPy. So you need NumPy, you need SciPy. Matplotlib is for visualization. You want to plot a graph or you want to visualize your data. So you use Matplotlib, and so on and so forth. So many of the modules, there are many modules. Okay, many modules. So depending on what you want to use Python to do. Okay. So, and Python is very easy to learn, as you will see. Very easy to learn. Now, there are people who have some criticisms about Python. Though I think many of them are not genuine actually. So one of them is that they said the speed of execution of Python program is slow compared to compiled languages like C and Fortran. Okay, but there is a solution to that. The solution is anytime you have large data sets, so you make use of NumPy and SciPy. If you make use of NumPy array, so you use array with NumPy, if you do that, your code will be almost as fast as a C code. Your code will be almost as fast as a C code. So that is not a genuine problem now. I mean in 2024. Okay, it's not a genuine problem. So Python code can be very fast. Okay, so I can write a Python code that will have the same speed as Fortran, and I've done that. Okay, so you can actually speed up Python, but you have to learn the tricks. You have to learn how to use arrays. Okay, you can use multi-dimensional arrays for your problem. Then the second criticism of Python is that it is hard to hide the source code. But actually I don't think this is a serious problem, because if you develop a Python code and you put it online, so everyone will have access to the source code. So that is not a big problem. I mean in 2024. So we are in the era of open knowledge. So we want knowledge to be free. So it's not a big problem. Then the third point is that they said that Python, the development of Python is too rapid, and there is a change from Python 2 to Python 3. But I think this has been laid to rest, because in the past 6, 7, 8 years we've been using Python 3, or up to 10 years we've been using Python 3. So there is not much problem. So because in the past we were using Python 2, but Python 2 was slow, so there was a switch to Python 3. But for now you see improvement, maybe Python 3.11, Python 3.12, and so on. Okay, but Python 3 is going nowhere. I mean in the nearest within the nearest future. Okay, so this is not a big problem, okay, per se. So now we are going to use Python 3. Python 2 is old school, but of course you can still run Python 2 codes. If you have them, you can still run them. Okay, but anyone who wants to learn Python 3 now, Python now should learn Python 3, because from like 10, 11, 12 years ago, so Python 3 is what people have been using. How do you install Python? You can go to Python website and download the Python program and install on your computer. Then after that, you download NumPy, you download SciPy, Matplotlib, and so on. Okay, you can do that. That's a way, but that is not a good way to install Python. The best way to install Python, or the easiest way to install Python, whether you are a Windows user, or a Mac user, or a Linux user, is to download Anaconda. Is to do what? Download Anaconda. So if you download Anaconda, so Anaconda will contain many modules. It contains many Python modules. Anaconda contains many Python modules. Okay, so that is the number one point here. Anaconda, and it's freely available. You can download it. Though the size is around 500, 600 plus megabytes. So you download Anaconda and you install. So if you do that, you have many packages already installed for you, instead of downloading and installing them one by one. Okay, so that is the method I would recommend for you to install Python. Just download Anaconda. Search Anaconda on Google, Anaconda download, then download Anaconda and install. Okay, so for those of you using Windows, so you can click on Start, then maybe type Spider. So Spider is an IDE of Python, and it is what I would recommend for beginners. It's an IDE. So you open it, Spider, SPYDER. Note, SPYDER. I'm using Linux, so I'm going to open my Spider differently from the way you open it in Windows. So in Windows, just type Spider when you click on search. So click on Start, then type Spider, then open Spider. So this is Spider. Okay, so the advantage of this Spider is that you can, it's when you make a mistake, when there's an error in your code, it tells you that there's an error somewhere. For example, if you assign A to be 5, you say A equals 5, and you now say B equals maybe 20 or 10. So if you say print A plus B, this is correct now. But if you now say maybe B equals 10A, okay, B equals 10A, you can see there is an X mark here, meaning there is an error, because there is nothing like 10A. So it should be 10 multiplied by A, 10 star A. Okay, so there's nothing like 10A. So if you correct that, the error will disappear. Okay, you can also get a warning error. Let's say instead of writing B equals 10, you wrote B minus 10. Okay, you wrote B minus 10. So it will tell you that undefined name B. So okay, that is still an error. Okay, that is still an error. So the beauty of Spider is that it lets you know if there is a particular problem with your code. Okay, so I would strongly recommend that you use Spider. If I'm a beginner, for me, I don't use Spider, so I often use any text editor. So I'll just open a text editor and start typing my code. Okay, so I do that. But for beginners, it's good that you use that you start with Spider, so that when you become an expert, so you can use any text editor. Okay. Okay, I think we can stop here for the introduction. So we'll meet at tomorrow morning. I think our meeting is 12 o'clock. So we'll meet by tomorrow. Alright, see you tomorrow.